our lecture here, what it means by neural network. And we're going to look at the basic of neural networks. What are the components that we need to identify, we need to know before we develop our own neural network. So for example, we need to know what it means by neuron, layer, activation functions, loss, and how we're going to train our neural network. So this is the kind of the initial approach to neural network. So this one is back in 1989. So it tells us that neural network is a computing system made up of a number of simple, highly interconnecting processing elements which process information by the dynamic state response to the external inputs. This is our typical neural network looks like. So typically we have an input layer. So in this input layer is where all our input going in, and then we need to have a hidden layer where we have all the processing elements, and then output layer is where our output is. So a neural network, or we usually call it as the artificial neural network. So in the simplest kind, we have artificial neural network, which is ANN. So it is processing devices that are loosely modeled after the neuronal structure of the mammalian cerebral cortex, but on a much smaller scale. So a large N, it might have like hundreds of thousands of processor units, where for the mammalian brain, we have billions of neurons. So for the model that we try to form, actually, we maybe just have like hundreds or thousands of processing units compared to the one that we have in our brain. So although NN researchers are generally not concerned with whether their network accurately resembles biological system, but some may consider it as referring to the biological system of the human. For an example, the researchers have accurately simulated the function of the retina and modeled the eye quite well. Although some mathematics involved with the neural networking is not a trivial matter, so a user can just easily gain at least an operational understanding of their structure and function. Basically, how it looks like, neural networks are typically organized in layers, made up of a number of interconnected nodes which contain an activation function. Layer here, if you look at this image, we have three layers. You have an input layer, and then you also have the output layer. The interconnected nodes here is our neuron. So we have X1, X2, and X3. We have three neurons because we have three attributes that we're going to fill in. So the first attribute is the customer age. The second attribute is the customer debt ratio. There's a typo here. And then you also have the monthly income. The patterns are presented to the network via the input layer, which communicates to one or more hidden layers, where the actual processing is done through the weighted connections. The hidden layer then linked to an output layer, where the answer is the output, with the different weightage that we provided from input layer connected to the hidden layer. And then after we've done with the processing in the hidden layer, and then we're going to pass the output to the output layer, where this is we're going to define what is the output. These are the basics terminology, some of the parameters that we have to determine in our neural network. First, we have neuron. Neuron is the basic unit of the neural network. So a neuron takes inputs, it does some mathematical computation with it, and then it produces an output. And then we're also going to have the activation function to compute an unbounded input into an output that has a nice predictable form. So a commonly used activation function is the sigmoid functions, where it only output numbers in the range of 0 and 1. So you can think of it as compressing the negative infinity to positive infinity to 0 and 1. Or big negative numbers becomes near to 0, and big positive numbers become approaching 1. This is our common activation functions, but we also have other common activations such as like ReLU. So this is our activation function here, the line when y equals to 0 and when y equals to x. We're going to get all the positive value. But if we're going to use the sigmoid functions, we're going to get a value between 0 and 1 as well. And other than that, we also have other activation functions such as the hyperbolic tangent. Okay, next we have neural network. So this is another terminology. It means a bunch of neurons connected together. And then we also have loss. Loss is a way for us to quantify how good it is doing, our model, the training model is doing, so that we can try to do better. Our aim here is to minimize the loss. Later, when we're going to train our model, we're going to observe what happened to our loss. You can see that as our loss getting lower, as the loss decrease, we're going to get a higher accuracy. Means we're going to have better prediction. Usually, we use this mean square error as our commonly used loss. Training a neural network here, it means to change our weights and biases to minimize the loss. An optimization algorithm such as the stochastic gradient descent is usually used. Learning rate, so it's a constant use to control how fast we train our network. These are the basic terminology that we need to know before we develop our own neural network. Here we're going to see what's the difference between a conventional computing and the neural network. For a conventional serial computer, it has a central processor that can address an array or memory locations where the data and instructions are stored. On the other hand, for the artificial neural network, we don't have a complex central processor, but we have many simple processors which take the weighted sum of the inputs from other processor. The conventional computing, the computations are made by the processor reading an instruction from the memory addresses, then execute, and the result are saved in a specified memory location as required. For the NN here, it do not execute program instructions, but they respond in parallel to the patterns of the inputs presented to it. And we also no separate memory addresses for storing data, so the information is stored in the activation state of the network. And then in the third point here, in a serial system or standard parallel, the computational steps are deterministic, sequential, and logical. So state of a given variable can be tracked from one operations to another. Compared to the artificial neural network, it's not sequential and it's not necessarily deterministic. Basically, neural network is a universal approximator. It works best if our system have high tolerance to error. So we're not going to advise a person to use their neural network to balance their checkbook, because this one we need to have a good accuracy, or we can't tolerate big error. And neural network is very well for capturing associations to discover what's the associations, or discovering regularities within a set of patterns. Some of the criteria here, where the volume, number of variables or diversity of the data is great, or the relationship between variables are vaguely understood, or the relationship are difficult to describe adequately with conventional approaches. These are some of the applications. We can use neural network for optical character recognitions, or fingerprint recognition, image recognition, face recognitions, stock prediction, statistical modeling, and data mining. So if you look at the first four here, OCR, fingerprint recognition, image, and face recognitions, these four actually are referring to the image processing. What are the limitations of the neural network? There are many advantages and limitations. So just like with every applications that we have pros and cons to it. To discuss this subject properly, we have to look at each individual type of the neural network. For example, here we have the backpropagational networks. There are some specific issues that we need to be aware of. Backpropagation neural networks here are, in a sense, what we call as the ultimate black boxes. Apart from defining the general architecture of the network and initially seeding it with a random number, we have no other role than feed the input, watch it training, and waiting for the output. Basically, what we do, we have the data set, we pre-process the data set, and then we identify what is our predictive features, what's the attributes that we want to feed in. For example, you have 10 attributes to determine the weather. So we have 10 neurons. So we identify 10 neurons, fed into the neural network, train it. So we only watch the training, observe the loss and the accuracy, and then you're going to have the output. What happened in the middle here, we actually don't really know. Except with the back propagations, you almost don't know like what you are doing. For the backpropagation network is also slower to train than other types of the networks, and sometimes we also require thousands of epochs. So if run on a truly parallel computer system, this issue is not really a problem. But if the backpropagation neural network, so this is the short form for it, is being simulated on a standard serial machine, the training can take some time because some machine CPU, it must compute the function of each node and the connection separately, and this can be problematic in a very large network with a large amount of data.